This is Mr. Martin. These are the final examples in the 6.1 continued and 6.2 chord properties video notes. So you can go ahead and check and see what you did. I'm going to work through these. So for the first one, we want to find the length of a chord that's 15 centimeters from the center of a circle with a radius of 17. So there's a lot of information, so just pick it all apart a little bit at a time. We've got a chord that's 15 centimeters from the center, so we need to draw on a chord. And here's the center, and we know that it's 15 centimeters from the center, so that's going to be represented by this distance, so that's 15 centimeters. And then normally, what we want to do is we want to draw in a radius that goes from the center to the end of the chord. This is a really common procedure. So we get a right triangle in here, and we know the distance to a chord is the perpendicular distance, so this is going to be a right angle. And even though we don't really need it for this problem, the radius perpendicular to the chord also bisects the chord, so I know that these two are going to be congruent. Okay, so the length of a chord that's 15 centimeters from the center of a circle with a radius of 17 centimeters. So this is going to be radius of 17 centimeters. And then what I'm going to do is I'm going to find x. And once I get x, since I want to find the length of the chord, I'm just going to double it. So I've got a right triangle here, so I know that x squared plus 15 squared is going to be 17 squared. So a little bit of algebra, x squared is going to be 17 squared is 289. And then I'm going to subtract 15 squared from both sides, and 15 squared is 225, which is 64. And then if I take the square root of both sides, I get x is equal to 8. And then, once I know that x is 8, therefore, length of chord is going to be 2 times 8, or 16 centimeters. And remember, if units are included in the problem, you should include them in the answer. If they are not included in the problem, you do not have to include them in the answer. Alright, moving on to part B. Find the distance from the center of a circle that has a radius of 10. Okay, so here's my radius of 10 centimeters. And the length of the chord is 12 millimeters. So I'm going to draw in my chord right at the end of that radius. And I know that this is going to be 12, but then I'm going to draw in the distance to the center. I know that's perpendicular. I know these are going to be congruent. So since the whole chord is 12, I know that this is going to be 6, and this is going to be 6. Let's change that to millimeters. And these are each millimeters too. Alright, so what we want to do is we want to find the distance, which is that perpendicular distance. And again, I've got a little right triangle, so I'm going to have x squared plus 6 squared is equal to 10 squared. So x squared is going to be 100 minus 36, which is 64. So x is going to equal 8 millimeters. Okay. So the distance from the center to the chord is 8 millimeters. So notice the pictures in these two problems are similar. We're going to have a picture like that very often when we're working with chord problems and distance to the chord. Alright, let's take a look at C. Notice I've got a circle with a radius of 18.5, and I have the perpendicular distance to a chord, so that means that these two segments have to be congruent. Okay, get in the habit of marking everything that you know. If I have a segment or a radius that's perpendicular to a chord, it's going to bisect the chord. So for this problem, really, we don't have to do any work. We just know x is going to be 16. Alright, over here in part C, I've got that the radius is 10.8. I know that this radius is perpendicular to the chord, so it's going to bisect the chord. Just marking everything I know. Since this half is 8.5, I know that this half is also going to be 8.5. Alright, and then I've got a little right triangle in here. Got a right triangle in here, so I can use Pythagorean theorem. So I'm going to have x squared plus 8.5 squared is equal to 10.8 squared. So x squared is going to be 116.64, that's 10.8 squared, minus 72.25, that's 8.5 squared, and then I'm going to take the square root of that answer there, so x is going to be about 6.66. So the distance from the center to the chord is 6.66. Alright, moving on to the next one. What's wrong with this picture? So let's see what we know here. According to the tick marks, based on the tick marks, the longer segment is the perpendicular bisector of the chord. And we have a conjecture says that the perpendicular or bisector of a chord goes through the center. So therefore, it should go through the center, but it does not. So either the picture is drawn incorrectly or that segment is not the perpendicular bisector. So one of those two things has to be the case. Segment either does not go through center or picture is drawn incorrectly. Let's take a look at the last problem. We want to determine true or false. CE is the perpendicular bisector of chord AB. So let's take a look at what we know. We can see that CE is a diameter, and we can see that FA and FB are radii, so we know that they're going to be congruent. And if we look at these two smaller triangles, I know that this would be reflexive. And we also know that since this big triangle here is isosceles because the radii are congruent, so those would be the legs, I know that these angles are congruent. And that's really about all that we know. And we can't prove these two triangles congruent. That would help us to determine if CE was a perpendicular bisector. But we can't because we have side-side angle here, and we can't. That's not one of our methods. So really, there is not enough information to determine if segment CE is the perpendicular bisector of chord AB. Alright, and again, if you have any questions about the problems in this video, make sure that you ask me when you see me in class, or if you want to shoot me an email so you don't forget, whatever is easy for you. But you know, all these examples are very important, and we're going to be doing more like these. Alright, we'll see you next time.